Now we will start our lecture from the definition of parabola. Okay, now look at this. So what is the definition of parabola? So it is locus of point which is moving in a plane, okay, such that the ratio of its distance from fixed point. Okay, so in this chapter this fixed point is having some unique name. Okay, like in circle you have a point which we call it as a center. So here also we have a fixed point and we will name it as focus. Okay, I'll change the color for that one. Okay, focus. Now, and fixed line. Okay, so we have another thing which is fixed and we will name it as directrix. Okay, directrix, okay, is always constant. Okay, so this is the definition for every chapter, means parabola, ellipse and hyperbola. Okay, so here we have a fixed point, we will call it as focus. So suppose that this is the fixed point, so it is focus. Okay, and suppose that this is directrix, fixed line. Okay, so you got your focus, you got your directrix. Now suppose that I'll connect with you like the definition. Suppose that this fixed point is S, okay, and the moving point is P, because it's a locus of a point, no, so it will keep on moving, so collection of points. So now try to connect with the definition. What is this one? So the locus of point which is moving in a plane such that the ratio of its distance from the fixed point. So first you have to give priority to this fixed point, means the distance between PS, point P and point S. So first is PS and fixed line. So second time you got fixed line. So this is the distance from fixed line. Suppose it is M. So PS by PM. And for this chapter we have special name for this ratio. We call it as eccentricity or it is E. Okay, so if I'll talk about E, I'm talking about PS by PM. Distance of point from focus and distance of point from the directrix. Okay, now look at this. I'll tell you certain conditions when this ratio will behave as parabola, ellipse, hyperbola. Okay, so now look at this. Suppose that eccentricity is 1, suppose. Okay, also h square is equal to AB. Okay, means ratio is 1 and h, you know that 2 degree, from 2 degree general equations. Okay, like it was what, ax square plus by square plus 2h xy plus 2gx plus 2fy plus c equals to 0. So we had this equation. So I'm talking about that general equation only. Okay. Now if eccentricity is 1 and or means h square is equal to AB, it is parabola. Okay. Or you can go with this part as well, like if eccentricity is 1, because it's a ratio now. It can be 1, it can be smaller than 1, it can be greater than 1. So now h square should be smaller than AB. So if you'll face this condition, it is ellipse. Okay, if h square is smaller than AB, it is ellipse. Now if E is greater than 1, so it is h square is greater than AB. So it is hyperbola. Okay, so these are the condition for parabola, ellipse and hyperbola. Okay, I hope till this part is okay, means like you know that it should be either 1, greater than 1, smaller than 1. Okay, now look at this. How will you memorize? The ratio is same, 1 by some same thing. So it is parabola. And hyper, you know, if something gets like too much, we call it hyper. Okay, so if it is greater than 1, you call it as hyperbola. Smaller than 1, equal to 1, and greater than 1, if you are comfortable, you can convert the smaller thing as well. Okay, so this is the condition. Now we will go with the definitions. Okay, like we will go with the first one, standard parabola. Standard parabola. Okay, now you know that in standard parabola means I'm talking about this situation. Look at this. Okay, like suppose, okay, suppose that this is the fixed line, directrix, and this is the fixed point, focus. Okay, so what I'll do, I'll call focus s as a comma 0 because it's a point on x-axis. Okay, so it's a focus. Okay, this is directrix. I'll name this thing as well. Okay, so you know that P is allowed to move. Okay, and the distance of P from S point, this point and this point has to be same. Correct, this point has to be same. Okay, this point has to be same. This point has to be same. Okay, this point has to be same. Correct. Now look at this. You know that this S point is a comma 0 and this is midpoint. Okay, so can I say that this would be minus a comma 0, this point minus a comma 0. And also you know that we will be having a as means x coordinate as same, x equals to minus a. Correct. So till this part you guys are okay. So right now what we get, we get we have fixed locus as a comma 0, we have fixed directrix as x equals to minus a. So suppose that point P is h comma k. Now I am applying restriction. You know that PS by PM is equal to 1, then only it is parabola. Correct, wrong? Correct na? Now let's go with the definition. So PS is equal to PM. So distance between P and S, you know that it is root over h minus a whole square plus k minus 0 whole square. Done with PS. PM is what? Distance of a point from the line. So can I write this line as x plus a equals to 0, है ना? And you also know that how we used to find distance, point satisfaction by root over a square plus b square. So I'll satisfy the point h plus 0 0y and then a. So point satisfaction is done. Now root over a square plus b square, है ना? So now look at this. Right now I don't know how to handle root and mod together. So do you have any idea by which we can get rid of this root as well as mod sign? Exactly, squaring both sides. Okay, so let's go with squaring both sides. So LHS will be free from the root thing. Okay, so can I write h square plus a square minus 2ah plus k square, and here also we will get rid of this mod sign, and also we will have h plus a whole square. So a square plus b square plus 2ah, है ना? Now you can play fruit ninja. H square gone, a square gone. So can I write k square is equal to 4ah? Correct? Now look at this. You guys have introduced h and k, correct? So you have to remove h and k by, means h comma k will be replaced by x comma y, है ना? So in place of k I have to replace y. So can I write y square equals 4ax? So this is your standard parabola. Standard parabola means the parabola which is opening right hand side. Is that okay? Okay now? Now I'll talk about some details. Suppose that, like, what you guys can extract. So suppose that we got this parabola y square equals 4ax. Okay, so we know that we got this parabola, है ना? Wait, no, suppose that we got this parabola, suppose. So you know that it is focus. Who is focus? We used to call it as s na. Okay, s is a comma 0. So can I say that if I'll ask about focus, you will say, sir, it is a comma 0. Now who is this? This is vertex. So can I say that vertex is, I'll assume it to be, I'll write a vertex only. Vertex is 0 comma 0. Correct? Now can I go with directrix? Who is directrix? We got x equals to minus a. Correct? Till this part you guys are okay? Now look at this. Axis of parabola. Now look at this. This is axis of parabola. Like, it is the line to which your parabola is symmetric. So this is called as axis of parabola. We can call this as x-axis. And also, like, suppose that we want equation. What is axis of parabola? Name it. So you can go with y equals to 0. On this line y will be 0 everywhere, no? So this is your axis of parabola. Correct? I'll tell you some details as well. Few more are left. Now suppose that, like, suppose that, look at this. This is double ordinate. Double ordinate. Like, you know that there will be lots of chords we can make, है ना? We can make so many chords. Okay, so suppose that we are dealing with certain chords which are perpendicular to axis of parabola. So we used to call those chords as double ordinate. The chords which are perpendicular to axis of parabola is double ordinate. Means, you remember that thing? Uh, x coordinate as called as abscissa, y coordinate will be called as ordinate. So here is ordinate. You know that if it is perpendicular to x axis, its x coordinate will be same, correct? So that's why we call it as double ordinate. So out of those double ordinates, we can have infinite double ordinates, but among them there will be one double ordinate which will pass through focus. Double ordinate which passes through focus. Okay, we used to call it as latus rectum. Okay, latus rectum. Okay, so this is called latus rectum. Okay, now can you please tell me end point of latus rectum? So you know that it is A, so here also it will be A, here also it will be A, है ना? So we don't have problem with x coordinate, है ना? It will be A only. We have problem with y coordinate, so substitute value of x as A, na? So you will have what? 4a 4a square. Okay, so can I say that here it is y square, so y square is equal to 4a square. So can I say y will be equal to plus or minus 2a? So plus 2a minus 2a. So this is your end point of latus rectum. I hope till this part you guys are comfortable. Okay, I'll ask you again, but look at this. Can you tell me the length of latus rectum? Length of latus rectum. I'll be asking you the same question infinite number of times. Okay, so distance means what? I'm talking about this distance. You know that x coordinate is same, so above x axis you have to move 2a units, below x axis you have to move 2a units. So don't you think it is 4a unit? Correct, wrong? Correct. So this many informations you have to hold. Okay, these technical words should be in good command. Okay, and also, like I'm telling you, if you will have great command over circle or straight line, if you will have great command over straight line, you can solve so many questions that belongs to circle. And if you will have command over circle, you can solve so many questions from parabola, ellipse and hyperbola. Okay, these chapters are so interlinked. Okay, hardly you will study new points in this part. Okay, we'll continue in the next lecture.